welcome everyone. So we're going to have the presentation, roughly an hour. Q&A can happen concurrently and then as a follow-up as well. So Daniel Slutsky is a co-organizer of Clojure, community for data science and Clojure, and is working as a data scientist at Localize. So I'm going to hand the reins over, and we will start the formal part of the presentation. So take it away, Daniel.
Thank you so much, Mark. Yeah, then I'll share my screen. And yeah,
Yep, we see it.
Thanks. For a while I had this feeling that this Boston group is such a special group that I hope to meet one day. And, John Anthony has been telling me, and then I met also Mark and Elena, and then Jeremy had this idea of suggested this meetup, and I'm so happy for this opportunity. And I already have this feeling like meeting a really wonderful group of people. So we will talk about data science in Clojure. And I wanted to talk a bit about the state where we are at the moment. And I like this sketch of Nathan Pyle. I think it tells a little bit about our process of sharing something, of building something and sharing it. And I think in this group and in other Clojure groups, I feel that it is okay to not hide all the troublesome details, but actually to share and discuss not only the beautiful part, but also sincerely where we are and what is still missing and what is still confusing. And that is what I hope to do today, in a sense. Maybe, oh, sorry, I'll hide this thing that is hiding a little bit of the screen, sorry. Yeah. This talk was assumed to be for people who already know a little bit Clojure and care about it a little bit. And by the conversation, it felt like it is the case. We'll not assume any data science experience. So please tell if anything is not clear enough. I think Mark kindly introduced me. So I work part-time at Localize, and this leaves me some time to be involved in Clojure, this community for data science in Clojure. And that is how you can reach me. And and it was nice that everybody, or almost everybody, introduced themselves. So I have a feeling now of the background of people, but if anybody wishes to tell anything else that is relevant, then maybe it is a good time to say something. And in general, I hope this talk will be interactive. Otherwise, I'll continue. So the plan is to have a short REPL session just for a taste of where we're going and what we hope to be doing. And then to have some thoughts about where we are, and then have more REPL and have another REPL session till the end of the hour. And then in the discussion stage, we can keep exploring things in the REPL, hopefully. Any thoughts, questions so far? I can hear you, but I cannot see because of the way I share the screen. So if there is anything, then please just shout. I think we are small enough to simply shout.
Sounds like a good plan to me.
Yeah, thank you, thank you. Great. So maybe let us have a short REPL session just for a taste of it. And yeah, so actually I took this open data set of Boston. These 311 service requests are complaints of people about all kinds of problems in the city. This kind of data set is, I think it has become something like the hello world of urban geography in a sense, because it is nice and it has some spatial features to look into, and it has some interesting problems. And for me, you know, it is also a habit when I go into a city that I don't know. There is usually some data set like this or another. So I hope we look into this data set of complaints, where, you know, a complaint about a certain problem is something that has time coordinates, but also spatial coordinates on the map and all kinds of metadata. And yeah, is it known to people, this kind of 311 service? I imagine it is, and I'm curious also if it is considered interesting to people to see what people are complaining about.
Well, I can say yes and yes on that. The city I live in, which is just north of Boston, Somerville, has a 311 service, and we are very strongly encouraged to use it for any and every concern or complaint or question regarding city services. And so it's really a great resource, and I would be fascinated to know how other people are using it. You know, is it just there's a dog barking, you know, at 2 a.m. and or is it more interesting kind of service complaints?
Yeah, wonderful. This actually helps so much. And so, yes, one thing we may do is searching for dog barking. And yeah, so maybe you'll open a new namespace and do some exploration briefly. And yeah, so I'll erase this. And you see, I'm requiring all kinds of data science libraries. We may mention some of them later. And some of them may be known to you. And we also have this helper namespace where I'm hiding some functions that will be useful for us. And maybe later we will dive into them. But that is actually a common habit, I think, in our data explorations. We try to build something and then add some functions for convenience, and then later make them into parts of our libraries. So that is what we have. And we have this complaints data namespace that has some data set in it. And yeah, let us check what the type of this thing is. So it is something called a data set, which is in a sense a table. It is part of this TechML dataset library that we'll look into more later. And we can look into it. Sorry. Yeah, and on the right, what we have is a tool called NodeSpace. It is one basic data visualization and literate programming tool, which means being able to write a document, a visual document of our code. There are more advanced tools, but my habit is to use NodeSpace. And here we can see, oh, actually, I should have updated the namespace. Yeah. So now we will see our namespace that we're editing.
A quick question.
Yeah.
Going from the 311 database to a TechML data set, is that a long process, a difficult process, or mostly something that's automatable?
Thank you. And please ask more quick questions like this. So here is the namespace that brought the data. You see, I have downloaded some CSV files, and I'm using this function of the tablecloth library. Tablecloth is a library that is wrapping the TechML dataset library for some convenience and consistent friendly API. And you see there is some way to read this dataset with some instructions like how should we parse the date columns, for example. And then I had 4 datasets for 4 years. So I just read all of them and then used some function to bind them together. And that's it in a sense. And then I just added some more columns for later.
And yeah, very simple. And so if you have a CSV as a starting point, you're already pretty far ahead in the game.
Yeah. And I guess later we will try more of this. And yeah, so maybe just for the taste of it, let us look into one row. So I'll mostly use this tablecloth API because it is so friendly and consistent. So for example, we can ask for the rows of the data set. Right, oh, we haven't looked into it. So the data set is a table. It is something like that, right? It has columns. It is stored in a column-wise way with some efficiency that we will discuss later. And you see there is some column about the open date of the complaint. And there are other columns like there is a photo sometime and there is the reason of the complaint and all other things. Also coordinates for geography, like longitude and latitude. So it is a table. And we can ask to see this table as a sequence of rows, where rows are just Clojure maps. And yeah, and maybe let us take the first of them, right? And then, yeah, we can see that it is a Clojure map. Actually, we haven't created a usual Clojure hash map here. It is just a view, a sophisticated data structure that is a view over one row of this data set. So you see, if you check for the type of this, it is some special data structure. So it is kind of efficient in memory and in time. And so here we can see all the different fields. Any comments so far?
Yeah, one thing I think is worth saying is that the data set is not anything like Clojure sequences of maps. It's a very optimized column store.
Yeah, wonderful, wonderful. Thank you so much for this. Yeah, actually, let us look into this. So let us look at the data set itself, right? So if you remember, it had this type, which is some data set data type. And actually, it is also a Clojure map. So it implements the relevant protocols and interface to behave like a map. And it means, for example, that we can pick one element of it by the key. So let us pick, for example, the month. Right, so the month, what is that? You see it is a special data structure, special data type called a column that stores numbers of type int64. So in a sense, it is something similar to a Java array for those who care about this. And so it is much more efficient in memory than storing the data set, the whole table, as a sequence of maps. Rather, it is a map whose values are columns. And yeah, any questions about that? John, you may have a comment.
No, I mean, yeah, I think maybe the other thing to say is that it's, you know, like the memory layout and everything like that is actually all rooted in C data structures. That's how Chris kind of put this all together. So it is actually extremely efficient the way it's all set up, and that it's basically very analogous to something like data.table in R, or pandas and or NumPy in Python.
Yeah, wonderful. Yes,
Cool.
and the key point here is maybe that we are talking about a data structure that has a fixed length and a type, which is a primitive type that allows to store things efficiently without having to create a Java object for every element. And yeah, and I hope we'll talk more about this. The behind the scenes, the basis of this is something called dtypenext, a library by Chris Neuenberger. Yeah, and maybe we come back to that. So maybe just for the taste of it, we'll just do one more thing. Yeah, you see, we have geography here because we have coordinates for geography, and we have a time axis. So we could do some time series analysis maybe later, but maybe just for the taste of it, let us look at pictures. So, so we can take the data and use the tablecloth to select all the rows by some predicate. So the predicate will be a function of a row. Oh, sorry for this. And yeah, my parentheses were broken. Yeah, so for every row, we can check, does it have this photo, right? And also we can check about with this row, we can check about the reason of the complaint and ask, is it a complaint about graffiti? Right? So, oh yeah, that does not evaluate. Sorry.
Mhm.
Yeah, so we get this subset of the data where we have photos and it is about graffiti. And then we can say, okay, let us take the photo column. Right, so we have yet another column structure. In this case, it is a column of strings, which are URLs. And then we can say, okay, we have some function to show these URLs as images. So maybe let us actually pick a few lines by random so that we don't have too many. So I'm just demonstrating some of the tablecloth API, which is so beautiful in my opinion. So we need to provide the seed and we need to say how many we take. So maybe 5. And then we can say, oh, sorry. And then we can just map over these by some helper function that creates images of them. So yeah, and maybe, and I have another helper function that shows this inside a div element. I mean, so that it shows on the browser. So yeah, something is wrong. So let us print this data structure, right? So it looks like it is okay. But you see, I print this data structure and it looks like the hiccup structure that I need.
Okay.
And then, yeah, maybe I'll restart just in case. Oh yeah, so we have some photos. And I find these really interesting to look at just to see what people complain about. So some of these were complaints about graffiti. Some were very interesting to me to see how people care actually and why. And yeah, so maybe later we can just look into pictures if it makes sense. So that was a small taste. And now let us go back to some thoughts. Is it okay so far?
Yeah, that's very cool.
Yeah, thanks. So, so Clojure and data science, I think a few people here in the introduction said they have this wish to be able to do data science in Clojure. So maybe I don't need to say so much about why I wish to do it too. I just say that I was lucky enough to be in some places where the groups were open-minded and we could use Clojure data science and enjoy it very much. But when the team grew bigger, the team decided to pick one technology for some standardization, and then they picked R. And I could see why. I could see that Clojure wasn't ready for all the convenience that is needed for a team to use it in some harmony and clarity that is needed in data science. And the hope is to change that. And I'm so happy that people are building wonderful libraries, and we'll look into some of them today. Yeah, let us talk about some problem that we have. This is a slide from this recent talk by Rich Hickey, a wonderful talk about the history of Clojure. And maybe you know this slide where, there is this Stack Overflow survey of 2 years ago, where Clojure was an extreme case. And what kind of extreme case? So you see, it has, on average, people who say they develop Clojure have a lot of experience in professional programming by average. And also the median salary is high relatively to other technologies. And yeah, and then of course, Rich Hickey comments that these are just the average, and the median salary, that is not the whole population. The fact that the average of professional programming experience is more than 10 years, it doesn't mean that all Clojurians have this kind of experience, of course. But actually, what about it? Let us try to look more into the distribution and then think what it means for us. So we'll go back to the REPL for a moment. And I have another namespace here of this survey data. And I'll evaluate it for a moment, and we'll look into some histograms to see the distribution of things. And we'll mainly focus on experience. Yeah, so yeah, it is evaluating, and we have some histograms. So it is all based on this very same Stack Overflow developer survey. And here we see the histogram of experience of all developers in the survey. And you see that some people have more than 50 years of professional experience, and many of them more than 8,000 have very little experience. I think that is 1 year, if I remember the number of bins. And yeah, is this concept of a histogram okay? Should I comment about it? I think not, right? We are just counting the different values along the axis of experience,
yeah,
right? And then let us focus on another language. If you remember, R was in the very far left of experience by average. So how does the histogram look for R, right? So, right, we see that maybe you can notice that it is not so visibly different, but it is a bit lower on the high experience parts, and relatively a larger part of the mass is concentrated on the left. Not so dramatic. Maybe there are better measures to see how this is different. Maybe people here will suggest something and we can do it later. And let us now look into Clojure, right? So you see, Clojure not only had a bigger average experience, but it is also very much distributed differently, right? If we compare the people of 10 years experience to those of 1 year experience, then it is more or less the same, which is not the case in the R community, at least for the people who took part in the survey, of course, right? And also this peak at 20 years, right? Very much different. Now let us look at people who reported working in data science, and you see this bias to the left, right? Very much concentrated on the less experienced groups. So let us think what it means for us, right? Does it mean that we have a problem when addressing data science? Or maybe not necessarily, right? So that is something that I hope we maybe discuss in the discussion part. And yeah, so you know, having this kind of distribution is also something that is wonderful, because we have these very wonderful experienced people with us who are building most of the libraries we will be looking today. And on the other hand, does it mean that the community and the ecosystem and the culture are not so much what is needed for newcomers? So of course it is an open question, and I hope we think about it a little bit. Yeah, so now one comment about the Clojure data science stack. So John mentioned it earlier, and now let us maybe look at this a screenshot from a talk by Chris Norberger, who has built some of the ecosystem. So Chris shows here an early version of what is now called dtype next. And you see, Chris is creating something that is implementing some interface. So it is some abstract notion of something that behaves like an array, but it is not an array. It is something that actually computes on the fly. If you see, if we ask to read the element at a certain index, then it just returns the index. So that is why if we look at index number 3, we get 3. Not because it is held in memory somehow, but because that is what it is defined to return. So this reader notion is still very much a central notion to the emerging stack of libraries through the dtype next library. And it is so powerful, and it brings up beautiful ways to build efficient computations, both in memory and in time. And in a sense, it kind of goes beyond what one is usually one can usually expect in the JVM ecosystem, because when we need something which is like an array, we don't need to create a Java array that takes memory and has some properties to it. We can create this abstract notion that could have all kinds of semantics to it. And behind this abstract notion, one could have not only something in the JVM, but actually something out of the JVM, like a Python NumPy array, or a file on disk, or just something complicated that can compute on the fly. So all of these could behave like an array thanks to this abstract notion. And yeah, and maybe we'll play with it a little bit later. Any question about this?
I think one comment that fits with what you're saying is, it's Chris put in a lot of effort in making this base level abstraction extremely extensible, or you can build things on top of it, and because it has that kind of Lego block kind of thing going for it, but it does it in this extremely efficient fashion. So it's really cool that you can just keep building new abstractions on top of this thing, and they all have high efficiency.
Yeah, wonderful. Thank you so much. So so after this small comment, maybe let us just briefly browse through the landscape of libraries. Yes. It is going to be a very partial list, and the idea is just to show where there is some activity. And if you wish, later in the discussion, we can kind of look back into this map and discuss some of the libraries. And so one area where there is a lot of activity is in data wrangling libraries, as they call it. Some of them are about sequences and unstructured data, which is, of course, so powerful in Clojure. But recently, we also have really great stories for array-like processing, Neanderthal and dtype next that was mentioned, and for tables. For example, mainly TechML dataset that was mentioned, and tablecloth that is wrapping it. And there are also some data wrangling libraries for specific domains that we may skip today. And there is a lot going on in data modeling. As John commented, that is, even if it is a lot, it is much smaller than what one has in the R ecosystem and in the Python ecosystem. And that is why it is important to also connect with them somehow. There is some things are going on in deep learning that we will not discuss today. There are really nice ways to work with Python and also Julia and Apple and other languages. And there was some experience with R also and Scala, etc. And there is a lot in data visualization that we will touch on a little bit. We can see it here, Hanami by John, that you may know, and other things like TechViz that we used for those histogram earlier. And there is a lot of activity in the tooling scene where, you know, we were using NodeSpace just because it kind of fit the need at the moment, but more amazing tools exist and more amazing tools are coming. And yeah, so that was a quick browse through that. And if you wish, we can come back later. Yeah, and yeah, thank you.
So for those of us who are not very well versed in data science, are there a set of well-known basic abstractions that are used widely? You talked about arrays, but and you know, tables and so on. Are there other kinds of abstractions? And I guess I'd also be curious to know, is there a known set of processing needs? You know, I've heard like data cleaning and normalization and those kinds of things, but I don't really know in the data science space what, you know, is there a top 5 list of things that you need in order to be effective with your libraries and tooling as a data scientist that, you know, we're trying to deliver with the Clojure data science efforts?
Yeah. So I think this question is so hard to answer because it varies for different practices and different cultures of data science. One thing that we are doing in order to try to have an answer for ourselves is looking into basic handbooks of data science of other ecosystems like the R ecosystem and the Python ecosystem. And then we see that, yes, data visualization and some ability to work with tables and some ability to do data modeling are kind of central to the story for common use. But then the specific kinds of models, they will really vary between different domains, of course. Yeah, so I think some part of the ecosystem that we are trying to encourage people to use is around tablecloth, simply because tablecloth is so cleanly organized, in my opinion, and so consistent in its API. And actually, it seems to cover the main functionality that one sees in data processing in other ecosystems. And then there is still the question of what to do with arrays, which are maybe at the moment a bit less user-friendly. And there is going to be some work there to have something like tablecloth, probably. And then in terms of data modeling, I think the biggest and most active effort at the moment is in Clojure, this machine learning library that is creating some common API to do machine learning pipelines. But I think there is still a lot to think about this part. It is a very opinionated API that offers some way to do data pipelines, which is probably not the only way to do them, even though, but yeah, it already covers a lot, and I think it is very smart about the way it is organized. And I think fast math is simply a wonderful collection of math and statistics and data modeling and clustering and other things that were typically, if you need some basic math or statistics function, you may look into fast math and hopefully find it there. And yeah, so these were maybe some of the main names to look into, but it is very much partial and it very much depends in a sense. Probably somebody has a comment about this.
So that was very helpful to me, and certainly the idea that tablecloth sort of covers the landscape. So we could go and look at tablecloth's features and capabilities, and that would give us a sense of the landscape.
Yeah, I think it makes sense to begin there. Yeah.
Great.
One other thing to mention in that slide, this with fast math and whatnot.
Oh yeah.
Is all the Sycamudal stuff.
Right.
Yes, thank you. Yeah, so actually,
yeah, like in particular the auto differentiation. That thing is just kind of stunning, really.
Yeah, thank you for mentioning that. So would you like to say something about it?
It's no. It's better for people to take a quick look at it. It's kind of an amazing piece of work, but it's so huge that just trying to say a simple thing about it is probably not going to help.
Yeah.
Yeah, there you go. Just put something up there like that.
And so Sycamutils is yes, it is an amazing library for symbolic math and differential calculus and physics, and it is based on a book by Sussman and Wisdom that was written in Scheme originally, and there is a lot to tell about it, and maybe it deserves a few meetings on its own. But please know that if there is anything that you're looking for in these fields, then that may be the place to look. Yeah. So we any more comments about this? Yeah. So we mentioned this problem of whether the ecosystem is ready for beginners, ready for people with less experience in Clojure and in general. And my feeling is that for that it is not ready yet. My feeling is based on trying to organize some study groups and noticing that some things were simply difficult to explain and some of the convenience layers were still missing. But I think we are getting there, and some of the community attention is on that side of the story. And yeah, I think, I think we should be thankful to be in a community where there is this collection of very experienced individuals, because some of the libraries we were mentioning were built by actually a very small bunch of very experienced individuals, including John here, who built Hanami and Saite and other things, and just a few others. And then we're wondering what we should do to kind of complete this with some layers of friendliness. And that is maybe one of the reasons we are creating some social processes around this small group of amazing library authors. And yeah, and that brings us to this topic of communication, of how we work as a community, as the Cyclodge community. And I really like this tweet by Paula the other day that kind of emphasized the need for communication in building things. And she continues, she goes on and explains a little bit of what she meant. But I think for us, it means a lot. And alongside the amazing work of library building, we have been doing in Cyclodge some human-related work in trying to be very much inclusive and inviting more people to join and trying to make the ecosystem a little more inviting to people who are new to the story. At the moment, we are focusing on people who already know Clojure, but the hope is to go and be able to do something with people who are actually new to Clojure, hopefully somewhere in 2022. Yeah, and Cyclodge has been a place for discussion, both for library authors and for users, and for some interaction between library authors and users, and just curious people who come to learn and try the tools and libraries. And there has been a nice talk of Sami that some of you may know about Cyclodge as a community and about some of the principles and challenges. So I think this story is told there, and what Sami said almost maybe less than a year ago, it is still very much relevant. There is also a nice conversation of Sami and like an interview by Jordan, where they really have a brilliant discussion of some of the human challenges of making a community inclusive and letting it grow in a healthy way. And and that deserves more discussion, maybe later in the discussion phase. Yeah.
So quick question
yeah.
about Cyclodge, and if we come back to it, that's fine. But I was just wondering if you can point people to where they could participate. Is this mostly a Zulip-based?
Yeah.
Activity?
So actually, one of the places has been the Clojurians Zulip, which is some forum structure that has been useful for us for discussions. And but we also meet face-to-face in small groups or one-on-one. And so I think a lot of the activity is actually by meetings. And maybe the best way to join or get involved is simply to reach out. I would love to meet and chat and think together how this community could be useful for you. But yes, the Clojurian Zulip is certainly the central place for discussions. And I'll share some presentation with links and all that later, if it makes sense.
Excellent, thanks.
Yeah, thanks. Yeah, and then there is this thing that we call study groups, where we are meeting to kind of practice together. And maybe what we do today, if we have a little more time for a REPL session, what we do is maybe trying to play in a format that is kind of similar to our study groups. And I think that is something that to me is very central to our efforts, just the ability to allow ourselves to be in confusion, in doubt, in uncertainty, and play together with the REPL. Sometimes some of our beautiful study sessions are mostly about trying to get what went wrong and realizing what was the bug. And it can be fascinating and useful as a way of actually learning the stack better. And sometimes we are actually creating things and analyzing data. And there are, I think, two main themes. One is building things together, which means actually learning to be library authors or learning to contribute to the libraries. And another is practicing being users. And there's this balance between these two kinds of practice, and we have study groups for both. And maybe this is, for me, the most important slide for today, because I really hope people find it useful to join our groups, and as an entry point to getting to know this stack of libraries, which is not so much visible yet because it is still evolving. And yeah, and I really hope if any of this is interesting to you, let us chat and think if you wish to join one of our groups. And yeah, and also I think in a sense, for me, being in Clojure, it has been my first experience, my first serious experience in doing open source. And it was an opportunity to work with wonderful people who have been guiding me and mentoring me. And I think Clojure can provide that for anybody who wants to do some cool open source stuff. And I really hope that people wish to think if they want to take on a little project and work on it. And just being able to work in a group and having this common sense of direction and relevance, and just being able to realize whether I'm going on a path that makes sense, thanks to the support of the group, to me, and I think to others, it mattered a lot in the process of writing open source. So again, please reach out. Let us talk if you find it interesting. Yeah, and then before we go back to the REPL, as much as we have time, we're wondering, are we ready? When will we be ready? What it means to be ready? What it means to say, yes, Clojure is ready as a data science platform. And recently I had a chat with Elena, and I think Elena had some idea that to me was actually a really great definition of what it could be. And that is something I think that John already mentioned to me in the past. And Elena said that it may make sense one day to organize Clojure Bridge meetings for beginners, for complete beginners who may like to learn Clojure for data science. And actually it may be very much relevant for the audience of Clojure Bridge who may be interested in data science. And just the fact that we are not ready yet for that, to me, it gives this sense of direction of what we need to achieve and how we can verify that we are there. And I think the day we will be able to organize a Clojure Bridge for complete beginners who want to learn Clojure for data science, for me, that will be the day we can say, yes, we are ready. And I hope it will be in a few months. And, you know, let us see. Any comments so far?
I guess I'm just wondering if everybody knows what Clojure Bridge is, or should we explain that?
Oh, yeah.
I know many people do here, and in fact, Boston hosted a couple of those, but I'm just wondering. So if anyone would like to know what Clojure Bridge is, please speak up.
I would like to know, please, if it's not too long or.
Yeah. Okay. Yeah, it's quick. So Clojure Bridge, yeah. Okay. Thank you. Is an outreach from Clojure community to underrepresented groups, in particular women. Although there's been talk about also hosting Clojure Bridges for other underrepresented groups. And living in Minnesota, I had discussions with several people about hosting a Clojure Bridge as an outreach to Native American communities. But currently it's mostly gender diversity. And they're typically a one-day event for various groups of people. They're international, so different cities do them very differently from what I can see. But they could be directed to people with some experience in other languages who want to learn Clojure, or they can be directed at complete beginners, or both in kind of two separate groups. So that's the short story. And there were a lot of them done about maybe 5 years ago, all over the world. Yeah, there were some in Berlin, London, Seoul, South Korea. What else? Buenos
Scotland.
Aires, I think. Scotland,
Like
yes.
Spain as well.
Yeah, excellent. Yeah. As well as various cities in the US. And now, of course, with COVID, it was kind of tricky. I don't know, they easily lend themselves to Zoom. It's kind of, the whole point is hanging out and having a real in-person event. I don't know if they'll be back. There was also a little bit of sort of tapering off even before COVID. But I do really hope that they would be back. And one interesting point about them is that several women whom I talked to or who filled in surveys in various places mentioned that their primary interest is data science. That's how they got to programming. And that's how they have heard of Clojure. So it is our audience. So that's probably a long answer to
Thank you.
that
It
question.
helped a lot.
Yes, in London we're running like 2 to 3 Clojure Bridge events a year. We'd get something like 20 to 30 women, and we'd have about the same number of coaches. We'd try to get like a 1-to-1 or 2-to-1 kind of ratio between them. So it was very much like a lot of hand holding, a lot of support on there, which is a bit more of a challenge to kind of do online. But yeah, it was really good, and everybody really loved it. Even the coaches really loved kind of like testing their knowledge and trying to explain Clojure to somebody else, which was a lot harder than they expected, but they really enjoyed it.
Yeah, Boston had, I think, 3 Clojure bridges, if I recall. And we had a slightly smaller ratio. So we had like 1 mentor per maybe 3 students, and that worked fine. But yes, it's highly personalized help. And
Yeah, we had
that's really cool.
two Clojure bridges at Akamai and 1 at MIT. And yeah, good experiences. So that makes sense to me as a long-range goal for Clojure data science usability, that it can be beginner-friendly and maybe even used for newcomers to programming. I'm still trying to get a sense of what the current state of data science and Clojure is regarding these efforts and what its promise is. So I guess if I was coming to this for the first time, didn't know anything about it, and someone was going to make a case to me that it is worth my time to learn these tools, adopt this ecosystem, climb this fairly steep learning curve. What would that case be? I mean, I've heard there are some very powerful, highly efficient underpinnings to the libraries, that there's activity going on in a wide diversity of different areas within data science, and sort of beginning to end pipeline. But I guess I'm still not sure whether, how far out is this future usability? How close are we? What could you do now with the tools? And can people do serious work and as opposed to some of the other more dominant data science languages like Python and R. Is there a case to be made, I guess, that one should try Clojure, that there's promise there, that it would be something that would be highly worthwhile?
Can I augment that question? I would say the best data science teams are using Python for things that Python's good at and R for things that R is good at. If you were trying to convince a data science team to add Clojure to the mix, not necessarily to replace the other, what would you use Clojure for that it would do better?
Yeah, great way to encapsulate that question. Yes.
Wonderful. Yeah, so I think that is a wonderful topic for discussion. Let us maybe think how much we want to dive into this at the moment, or whether we wish to have a little taste of a REPL session. Maybe first a discussion and then a REPL session. What would be good? What do you think?
I'm okay with that.
Yeah, so maybe let us continue with this momentum for a while and then go back to the REPL, if it makes sense. Yeah. Great. Yeah, so I think to what Mark said, my feeling is that we are a few months away, but I used to say that 1 year ago too. There is a lot of uncertainty in the process.
It's like fusion power. It's always 10 years away, even though for the last 50 years they've been saying that.
Yeah. So I feel that at least for the kinds of needs that I'm aware of, which are partial to the story, are very specific in the time series and geospatial analysis that I've been needing in my team, I think it is a few months away. I think in a few months, I could be able to offer it to a team like the one I've been working at. And but some focus is needed to get there in a smart way. And we are trying to do that nowadays. There is a group called Phase Transitions, which is trying to make this phase transition happen. And John practically and Elena are involved there. It is organized, facilitated by Ethan Miller. And there we're trying to have this thought process of how to make the minimal steps to get into something that can be considered good enough. And by this thought process, I think we are getting a better sense of how we could go there. And at the moment, it feels good. I think some things in the ecosystem are simply amazing. One of them is being able to work with unstructured data, which is so much needed. And I see this need again and again in Python and R data workflows, where that is the place where some frustration and pain appear, and where I wish I could use Clojure. And that matters a lot, I think, in lots of data problems. Just being able to work with any piece of data, no matter how it is shaped, and no matter what kind of things there are inside. That is one thing. Another thing is efficiency. dtype next is a game changer. I have been using Python NumPy and running into problems where there is just not enough memory. And dtype next has been saving me. I'm not saying that NumPy is the only thing to look into at the Python ecosystem, and there are now some other alternatives, but dtype next has been amazing in situations which are typically troublesome in R and Python, in my little experience. And I also think there is huge potential for being able to express yourself and quickly create interactive data visualizations. And I think that is something that, John Anthony has been exploring and demonstrating for a long while already. And the potential there is huge. And some of this hasn't been solidified yet as polished tools that everybody can grasp, but it is getting there. And then Clojure is going to have an amazing user interface as a data science platform that is simply unique. And I think just looking into the things that John Anthony has been doing in Site is a demonstration of this potential. Another thing is being able to connect to other systems because of this culture of Clojure, of being hosted in the JVM, hosted in the browser, and also being able to kind of communicate with other runtimes, which is very much possible in an efficient way thanks to dtype next, like the Python interrupt story. That means that the reach is actually very easy to lots of pieces of functionality which are not inside the JVM. Anthony Kong, who is here in this meeting, has demonstrated that with Apache Spark, where a beautiful Clojure API was built by Anthony Kong just to use the Apache Spark ways of querying data. And just seeing the beauty and simplicity of this, I think it is very encouraging. And of course, it is a matter of taste. Of course, it is a matter of taste what simplicity means, right? What does it mean, simplicity, right? But I think since here as Clojurians, we have a certain sense of simplicity. I think we have a certain sense of the joy that we can get when Clojure connects to other runtimes. So that was an attempt to answer why Clojure for data science.
So to follow up there a little bit, you said that you think you hope in a few months you feel comfortable bringing Clojure to your team. What are you hoping will change in the next couple of months that would let you feel comfortable bringing Clojure to your team like that?
Yeah, thank you. So mostly more layers of usability, because functionality is already magnificent. And, you know, more layers of usability mean that it should be obviously easy to use other runtimes such as Python and R. And that is almost like that, especially with Python, but may need some more user experience improvements. But it also means that all the kinds of functionality we were discussing, like data modeling and dtype next, should have an easy API around them that will feel friendly and consistent. And I think the tablecloth project demonstrates what could be done, because tablecloth took the amazing TechML dataset, which was already amazing, but a bit confusing, a bit inconsistent, and wrapped it in a very consistent and beautifully easy way. And just having more tablecloths around other things, I think that is the main need at the moment, in my opinion.
It makes a ton of sense. Thank you.
Wonderful. All right, any more questions, or should we go to the REPL?
I had a quick question. What happened to Encanter? When I first started using Clojure, that was kind of the data science library. It seemed like it hadn't been updated for a very long time. Did all these new libraries supersede that? Do they complement it? Is there still a place for Encanter?
Yeah, so possibly more people here can comment, but Encanter was not built in a way that is as efficient as TechML dataset and tablecloth.
Mm-hmm.
Possibly it had some ideas of usability that could be copied, or at least some part of them, and it could be a great candidate as a wrapper to nowadays better, more efficient functionalities. So actually it is still an important experience to learn from, I think. And some people have these thoughts of maybe bringing it back, with a new backend in a sense.
Yeah, I noticed Incantor is mostly inactive now. There's 7 or 8 years since there have been updates. It was great in its time and maybe something to learn there, but as a path forward, it would have to be picked up again and made active. Okay.
I have a couple of 2 cents to throw in on this. And my personal feeling is that the data wrangling part is pretty much totally there. I would say you could do data wrangling in this current set of whatnot far better than you can do it in Python or R. So the piece that I think, and I've mentioned this to Daniel and other people several times, that I think is missing is, but you can get at it by calling out the R using Clojure, which actually is really nice. I mean, it's a tip of the hat to Daniel's work there, which I think is really quite nice. But I think we need a handful of capabilities for modeling before you could actually say, hey, I can go soup to nuts in Clojure for a very large set of kind of day-to-day things. In particular, I would say we need something like LM and GLM from R.
Can you mention what they are?
Well, LM is for doing linear models, regressions, modeling using linear regression models, and GLM is just to generalize linear models. If you had those 2 things, I think you could do an enormous amount, soup to nuts, with Clojure right now. But we don't have those 2 things just yet. So I have, since I've hit this problem recently, mostly myself, I have been toying with the idea of doing an LM and maybe a GLM using Neanderthal as the basis for the thing. And then of course,
you mean actually implementing the algorithms?
Yes, yeah. I don't think it's that big of a deal, and Neanderthal would be just blistering fast.
Yeah.
And the nice thing is TMD already has a Neanderthal ability. So
can you mention what TMD is?
A TechML data set. We've already seen this several times now, but one of the, I mean, TMD is brilliant because it does no copy interaction with things like NumPy arrays and also Neanderthal arrays. So it's a great way you can do your wrangling and then be able to create the matrices that Neanderthal would then crunch on. So anyways, I'm toying with that idea. So I think that would be a case then. I mean, it doesn't cover everything, but let's face it, those 2 simple, quote unquote, simple things underlie an enormous amount of kind of ordinary, boring, day-to-day data science-y type stuff.
Great. Say we're an hour and a half in. I'd like to suggest a 5-minute break before we jump into the REPL. So if there's any more comments or questions, observations before we go to the REPL, let's do that now, and then we'll take the 5-minute break. Okay, nothing? So, all right. All right, well, we're back after our brief break. So Daniel, I believe you had a REPL session that you wanted to conduct as the next step in our our meeting. Are you ready to go?
Yeah, thank you. Thank you. So in the beginning of the meeting, we briefly looked into two data sets. One was the Stack Overflow survey, and another one was the 311 service requests in Boston. And we can look into either of them. Maybe the service requests will be a bit more interesting. I had some brief session about it with our friend Raja Gopalan Siddharthan. And also recently I had some sessions with our friend Ashima Panjwani about data visualization, trying to learn different ways to use Hanami, the library by John Anthony. And so I'm a bit affected by these recent sessions, and maybe what we'll see is a bit about data visualization and time series and that. So yeah, maybe let us look for a moment and into this data set of complaints.
The 311, yes.
Yeah. So right. So.
Oh, and there was a question in chat whether there is a line template to start a data science project, and John answered that he wasn't aware of one. So I'm just bringing it up in case there is something that.
Yeah. So I think, in my opinion, we're still figuring it out because there are so many opinions about the tooling and setup. And actually, the plan is to have some opinionated suggestions soon, and maybe in the coming month. But yeah, now I don't know what to say. John has been building some interesting templates, and I think they are wonderful. And we will be looking into them a little bit more. Yeah, so I'll share the screen again. Right, so remember, that is a typical row of this 311 data set. And you see we have different fields here, maybe just to get the impression for a moment. So you see, since we have latitude and longitude, then we can draw things on the map. We also have a neighborhood, so we can group things by neighborhood. We have time, so we can look into time series. And yeah, so maybe one thing we could look is how the complaints of a certain kind were changing throughout the months of a certain year. Would it be interesting? Another thing we could do, yeah, let us try it.
Well, for example, do they spike on Saturday night when there's a lot more social activity?
Yeah, let us try that too. Great. So yeah, maybe let us create a new namespace. Let us call it complaints days. And yeah, oh, again, I need to change the namespace, days. And yeah, so let us try to look into the weekdays, actually, as you suggested. So first, let us pick this column of the date and time. And see how we can work with it. Right, so that is that. It is one of the date time types which are supported by dtype next. And dtype next has this flexible functionality of picking different time transformations in a rather comfortable way. And let us try it. I never tried to extract the weekday, but usually the general place to look is this namespace, TechB3 data type date time. And it has a lot of functions. One of them is long temporal field, which is maybe a bit of a strange name, but that is what one usually does to do date time conversions. And you see what we're experiencing here is this dtype next library, where the API is amazingly powerful, but sometimes a bit confusing. And that is why we're saying we may need another tablecloth to wrap it in a sense. I think, yeah. So I think, yeah, maybe it expects this other order of arguments. And then we could say, for example, years. So let's see if it works. Yeah, let us actually skip the browser view and use the editor view for now. So, yeah, my editor is stuck. I'm actually happy that it happened, because that is typical. I think that is one of our main problems with the ecosystem, that these things sometimes break. So I'm going to kill the editor, I think. It's stuck actually. Yeah. 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 So kill all. Oh. Why is it? Oh. Why am I writing capital letters? How did this happen?
The only thing I can think of is the shift key got stuck or something.
Oh, maybe I pressed the wrong key.
So
that is interesting. Yeah, maybe I switch the keyboard. I apologize for this. That is interesting. Yeah. So, yeah. No. I'm wondering what I should do. Any Linux expert can tell me what I should type to exit this caps lock. Oh, that is interesting.
You could try, well, it probably won't work, but you can try reset.
I mean, you mean of the machine?
No, just type reset.
Oh.
That doesn't work, but anyway.
Yeah, so I think I'll leave for a short while and join again. I'm so sorry.
No problem. So you're going to did your caps lock?
Yeah, restart was a magic, an actual restart. Thank you for your kind patience. So I'll share the screen again. And what we were trying to do was to do this conversion of date time object to a day of week. And I hope we make it work. Maybe here my ignorance about the daytime, the date time namespace will stop us. But right, so let us look what this thing is, right? So what we saw earlier was actually something important about the state of the ecosystem. You see, sometimes when we print stuff, it prints too much, and then the editor gets stuck. And that is, I think, a good example for the state where we're at, where a little more polish could improve the situation, but that is not there yet. So now you see, I took a sample of the data just to be sure that I'm not printing too much. And that is this date time column. And now we can try again to do this transformation of this date time long temporal field. And this is a function that gets the date as the last argument. So I use the other threading macro. Sorry for this. And let us try years, because I know that it works. So you see, I took a sample and we see the different years of these date time objects. Does it make sense? Right? Maybe not all of it, maybe some of the API isn't confusing, but you see there is this function that takes a whole column or array-like data structure and converts it to a different kind of date or different kind of date type. So we could take months 2, and it would work. Now, I'm not sure about where to look in the API. Days. So days are days of month, day of week, I hope. I just don't remember. Yeah, so day of week turns out to be the way to extract the day of week, right? So let us try that. So we can take our data, and maybe now we will add a column of the day of week, right? So how do we do that? Tablecloth has an add column function. And many of these tablecloth functions, they can get different types of arguments. They are very flexible about how we can express what we want from them. One way to tell how to add a column is to say the name of the column. Let us call it day of week, or maybe day of week for short. And then we can give a function of a whole data set that says how to extract this column from any data set. So let us do it. We take this data set. We take the open date column of it, and we do the previous transformation with the different threading macro because of the order of arguments. So now we created a new data set that has an additional column called day of week. Let us try to print it. Maybe, yeah, we can try to print it. Right, so that is the new data set, and the last column is this day of week, right? And only 25 rows are printed by default, but we see that we got this new column. And just this fact that most functions get a function of the data set as the way of expressing the data transformation that we want, that is actually really handy, because it works really nicely when you are threading a lot of operations in a pipeline. You see, we could do more add column and drop column and more all other kind of things. And still it would make sense, because for every step, it gets a function of the current data set. So it is a really nice way, a really nice choice of tablecloth to do that. So now one thing we can do is group by. Let us do it. We can group by. It is similar to what one does in relational databases, right? We can group by this new column. And what do we get? We get something that is called a grouped data set. If we ask, is it grouped? Then it says, yes, it is a grouped data set, which is a special kind of data set. You see, it has only 7 rows for the 7 days of week, right? Each row here has a whole data set inside this data column. So let us print it a bit differently. There is this print namespace that helps us change the printing defaults. So we can say print and use a different print policy. There is some print policy called REPL. And if we do that, then you see we get a very detailed printing of this grouped data set, where every group has a whole data set inside. Does it make sense?
Yeah.
Now, the happy news are that we didn't actually copy a lot of data now. These data sets, which look like new data sets, they are actually views over the previous data set. So really almost no new memory was allocated by this grouping operation. These are views, as in database views, right? And they are very efficient thanks to dtype next. Does it make sense?
Yeah.
Great. So now we can take this and we can do some aggregation. So for example, we can say, please aggregate And we can specify how to aggregate. So we can give it a name. We can say, for example, we want to say the count. And this count, how do we compute it? Again, by a function of a data set. So this time, the function of a data set will operate on the data sets inside the structure, on these. Right? So for any of these, we want to do some summary. For example, we can count the number of rows, right? So we can say tablecloth row count of this data set, right? And this will give us this summary of the row counts of these groups. Now, just let us notice that we could write this more shortly. This is just the row count function, essentially. So we could just write it this way, right? Great. Is it good so far?
Yeah, are these counts then representative of the number of calls on a given day of the week?
Yes, exactly. Thank you.
Okay.
Yes. Yeah. So now let us plot it, right?
Yeah.
So here I have some helper function that is trying to mimic some of the ideas that our friend Ashima Panjwani is experimenting with a new data visualization library. That is actually an interesting story because I think most of you, or at least some of you, know the Hanami library by John here.
Yes.
Which is so expressive and flexible. And some users were commenting that a little bit of Hanami was confusing to them. So Ashima is exploring how it might be possible to build upon Hanami with maybe an API that may feel a bit more restrictive, but still, but maybe a bit less surprising to some users. And she has been trying lots of ideas. And one interesting fact about the process that Ashima was doing was that in the process, gradually, she saw again and again that when she tried to restrict parts of Hanami, there was a cost to it. And I think that is something that John has been saying a lot, that Hanami and its idea of templates that we will see in a moment has this flexibility that makes use of the power of Clojure with data structures. And when we try to lose this flexibility, there is a cost of losing some abilities. And eventually, when Ashima looked into it for a while, she converged to APIs which are very similar to Hanami, actually. And in a way, we, by the process she was sharing with us, we were rediscovering what John has been trying to tell us by Hanami. Does it make sense? Or maybe John wants to comment more about it.
No, not really, because this is the first time I heard about this.
Yeah, that is the kind of thing that happens in the study groups, by the way. We're having lots of processes. Some of them are recorded, but not publicly, more for sharing internally in the community.
Yeah, one thing I think maybe what you're getting at is in the past, I've said things like, if you go down like, well, I don't know, the so-called helper function route for trying to abstract Vega or Vega Lite or something. I mean, eventually you either end up in a dead end or you kind of end up trying to reinvent the template thing all over again.
Yeah.
Nice validation.
Yes, yeah, and we have been experiencing that, and that is why I really like those study sessions, right? And by the process Ashima was sharing with us, we learned a lot about Hanami, and still I'm kind of hopeful about what she's building, and maybe it will bring a little more convenience. Anyway, this function I have here tries to do something like she is building, so it looks very similar to Hanami, but you see, we can use this in a way that fits the pipeline so that this function gets the data set as the first argument. And then we can say, we can pick some Hanami template, like a line chart in this case. And then we can provide the other arguments, like, for example, what will be the x-axis? So it will be the day of week. Oh, x. Sorry. What will be the y-axis? It will be the count, right? So, yeah. So let us look into this. And now we can bring the browser back. And maybe, oh, all right, because I wrote Hanami here. Yeah. So it evaluates. And you see this thing, when we evaluate it, it is just resulting in a Vega Lite specification. Right. Vega Lite is this client-side data visualization library with a grammar of graphics. And that is the magic of Hanami, that it has this powerful template system to create specifications for data visualizations and other things. And another thing that is coming soon is a more efficient way to pass the data. Here you see we're passing it actually inside the spec. So we're actually passing a huge JSON structure to the browser if we want to view it. So it is kind of heavy, but more efficient ways are coming soon. And yeah, so here is the plot for the day of week. Does it make sense? So it is kind of strange because we hoped the x-axis will be integer, and do you know, John, how to communicate that we want the day of week to be integer? Or maybe it should be nominal, right?
It would, I would say if you put X type ordinal.
Ordinal, thank you. Yeah, the most fun thing, the most fun way to visualize things is to have John around. Yeah, beautiful. Great. So Saturday has less complaints in general. Sunday has more. I think that is the right interpretation of the number for the day of week. Maybe I'm wrong, right? Maybe 7 is Sunday. Should we check? Yeah, actually we should check, right? So sorry for this. I know it is late, but we have to check, right? So let us sample one day and do it once this way. So that was June 12th. June 12th was Saturday. Mm-hmm. Now let us convert it. So it is 6. Okay, Saturday is 6, Sunday is 7. Now it makes sense. So sorry for the previous interpretation. Is it okay? So by this plot, we see that the weekend has less complaints in general. Now what we can do is to pick a certain kind of complaints, right? So yeah, let us, if we have just a few more moments, we can look into the kinds of complaints, and please tell me when it gets too late and we need to conclude. So we can count the different kinds of complaints, and maybe this will, the different kind of reasons for complaints. Maybe it will help us to remember. So, oh yeah, maybe let us sort this by the reason count. Yeah, did it? Oh, reason count, sorry. Yeah, so should we guess one or two kinds of complaints and try maybe to hope that they have more complaints in the weekend? Or will it be too difficult to guess?
I was thinking noise might be more of a weekend thing. But
Oh, thank you. Let us see if we have noise. Noise disturbance. Great. Let us try. And then maybe if we have more time, we can compare two plots or something like that, right? So for now, let us just filter, right? So select rows gets a function of a row. So for the row, we can check the row, the reason of the row. Is it noise disturbance? Does it make sense?
mm-hmm. Yes.
Yeah. And yeah, wonderful, beautiful, just as you said. So noise is more frequent in the weekend. That is beautiful. Isn't it beautiful? Yeah. So I'm not sure how much time we have. We could draw maps. We could color the plots with a few layers on top of each other. We could do things. Thanks to Hanami. What do you think? Should we continue a bit or should we conclude?
Well, what do people think?
Might be a good idea to have a bit of discussion and kind of wrap it up. It's 11 o'clock in where you are, right? Daniel?
Oh yeah, it is. Yeah. you can know the conversions somehow. Yeah.
Google
Yes.
helps.
Oh yeah. So by the way, a short comment. Sorry. So that is one kind of thing that we do in the study groups. If anybody is interested in just continuing this REPL session, then let us just meet and continue, whether in the weekend study groups or in a one-on-one session. I would love to continue with that. And having a Boston person with the interpretation of Boston data will help me so much. So yeah, anyway, please reach out. Sorry. Yeah.
There is a raised hand.
Yeah, that's me.
Yeah.
So I just had a question. I mean, so I know John Practicali has a book that he's writing on his site. Is that actually going to be using the Clojure stuff?
Not well, I don't know. That's still to be decided. It's just like for me to start capturing some ideas about data science. I guess I'm kind of coming from like somebody with absolutely zero experience with data science, where Clojure is kind of slightly more kind of experienced, but then working towards people who are just starting in data science. So kind of like coming from both sides and meeting in the middle somewhere.
Gotcha. Okay, gotcha. And also one other quick question. Someone said that there was a good library in Clojure for symbolic reasoning. Is that, I just wasn't able to write it down fast enough before I forgot. Is it like
It's probably the sick and util stuff.
util stuff? Say again. If you can write that in the chat, and then that way I can copy.
Yeah, let me put that in.
Cool. Well, that's all I have. But thanks.
I have a comment that I think this sort of thing would be really fantastic for Clojure Bridge, because my sense is that lots of people who go there kind of expect that sort of thing.
That is practical kind of results, right? That you could take home and start using in a very useful way.
Yeah, I think this would be a great thing, and also a great thing for a class, because learning programming and looking at real data sets certainly would attract, well, I mean, I think now lots of assumptions about introductory classes kind of are that it's video game kind of stuff, which was a selling point some years ago. And I personally don't think it brings the right kind of people or lets the right kind of people stay. So
yeah,
I think this would be a better approach to have students do something really helpful, really practical that they can use in day-to-day life. And that is one thing that tends to attract and keep a more diverse group of students. So I think this is great all around.
yeah. I was very impressed how straightforward the ability was to take this this data set and make you know, do groupings and filtering and all the kinds of manipulations that get you to quickly show patterns and aggregations that you know, answer questions that people would have, natural questions.
Yeah.
What are the most noise complaints? And you got there in very few steps. So that kind of procedure, if it could be turned into sort of a recipe that people just coming into the field could use, they could be productive in this environment very quickly.
Yeah, the process that our friend Tomasz Sulej did with tablecloth, it is amazing. The fact that he managed to create something that feels unsurprising and familiar, that is outstanding. The little trouble is that this kind of wrapping is just a little bit missing in some other parts of the story.
Okay.
And yeah.
And of course, there's a lot of language fundamentals that many of us are sort of assuming are already second nature. So it's not like you take a non-Clojure programmer and have them doing this stuff, you know, in a day or two. But definitely shows the value and the promise, and would motivate people to pursue it because of its power. So yeah, this was great. It was fun to have the Boston data set as your example. It proves that you didn't just can something, you know, some fake data set that was super easy to work with. This was chosen sort of very specific to our session. And so you can work with anything with these tools. So that's great.
Yeah, another thing that works really, really well, in my opinion, is TMD, the XML data set, also has a really nice interface to SQL. So you can plug it. Yeah, I use it a lot. I think in many ways, in some ways, it's the best kind of interaction that I've done with databases, even more than, you know, some of the GUI-based tools.
So instead of CSV, if you're hooked up to a relational database, you can
you can
work in these same kind of abstractions.
Yeah, you can create joins, do anything you want, and then pull it in as a data set, or write a data set out as a set of tables.
Oh, cool. Yeah, that expands the reach of this quite dramatically, right? Not everything's in CSV form. So.
Yeah, TMD will also eat things like JSON. So yeah, I mean, CSV is almost like the lingua franca though in data science.
Yeah. But there is awful lot of JSON and relational data out there too. So.
Yeah, exactly.
Well, excellent. All right. where do we stand in terms of the agenda? Anybody else have something they'd want to see, or comments, questions, observations, or are we ready to wrap it up?
I feel like things are relatively complete as it stands.
Yeah, this was a really interesting, illuminating session for me. I have been sort of around the fringes of this stuff, but it's great to see how far it's come, and I'm eager to dive in and start doing some more hands-on.
There is a question in chat. Where can I find examples of using Clojure to work with unstructured data, which I think is, yeah, we can pretty much have another session here. Maybe that is a topic for another talk.
I would like another talk on unstructured data, because I have a project that I sort of abandoned because the data doesn't conform to a nice tree structure. And yeah, would love to learn some techniques to wrangle that.
Yeah, it's not just the unstructured, but data that has inconsistencies, gaps, and flaws.
Yes.
That can be a real challenge, and I think Clojure can shine there.
Actually, in some ways, I would say almost every other example of Clojure probably is involving unstructured data in some way. You can make an argument for that at least. And actually, Mark, in terms of your, yeah, there's a bunch of stuff in TMD and then with tablecloth or the top of it to help with bad values. To filter that kind of stuff out and change it in sensible. It's in that sense, it's very similar to stuff you got in R or Pandas.
Great, good to know. So TMD and tablecloth, they seem to be like the crown jewels of this this effort so far.
They're almost like you know, the foundation. I think that along with Neanderthal and I think are like the foundational things. Yeah.
Excellent.
Yeah, if I may comment briefly. So if you have any unstructured data problem, then you may wish to consider to bring it to one of our study sessions. We like to meet and play with data, and we like that people just bring their problems, and then we can just see how the tool can fit the problem. If it is something that cannot be shared publicly, then we can have a non-recorded session, and it is just fine. And if it can be shared, then wonderful. So anyway, everybody is invited always.
Well, wonderful. Well, thank you so much, Daniel. This was excellent session. I really enjoyed it. I think if we can provide a couple of pointers or links for people so that they can further their explorations, get involved with the community, and continue their learning journey, that would be very helpful.